What is up, most distinguished patrons of this channel? Today we are going to go on an adventure of fixing some broken shit that took a lot of work. So that's what we're going to be covering today. Let's get into it. Recently I was put in charge of fixing a clam bucket of sorts, and I put a picture of what this bucket sort of looks like. It's not quite like that, but it's a front end loader bucket that's designed to grab debris and trash. Now this particular bucket happened to be in more or less a landfill, so it was full of baby diapers and trash. I had to clean it all out before I started working on it. Not fun. But anyways, the picture up there depicts what we're dealing with. And the picture in the background, which I'll show you now, is the actual bucket in question. Now, this is at the end of the repair when I repaired it, but I took a couple pictures along the way of the repair process. Didn't take a whole lot of them, but we're going to go through them and talk about what I did, why I did it, and the mistakes that I made, and hopefully we'll all learn something. So let's start out at the picture of what the problem is. So here we have the right side of the bucket. The pin snapped somehow, not really sure how, and ripped basically that right lower mount off, and the left one was pretty close to it as well. Now this is a prime example of a somewhat difficult to do repair, but if you follow the simple steps of, well, cut it all off and replace it, it's really not that bad. You kind of have to take the big job and turn it into a bunch of smaller jobs to get through something like this. About 5 whacks with the finger finder and this fell off, so clearly it was barely attached. And by the way, this is a pin that holds that hydraulic cylinder to the bucket, because the clamming mechanism, you can clamp down on stuff in the bucket so it doesn't fall out. Normally they're used for tree and leaf debris, but this one was repurposed for landfill duties. So you can see how poor that base material is. It's more or less cracked and shattered all the way through. Over the years, I've gotten in arguments with people where a lot of people just take the approach, well, just grind that down with an angle grinder and reattach what broke off. The truth is the material is so fatigued and stress cracked that doing that isn't likely going to give you a lasting repair. So you're going to find that I just torch cut back far enough to where I know I'm in clean material that isn't fatigued. On the topic of fatigue, anytime you do repairs like this, you really need to take a look at everything and come to a conclusion on what happened and what's going on. Now this pin shows rust on over half the diameter of it, which is a pretty good indication it had been broken or cracked for quite some time, and then it more or less failed, and the failure led to the ears being sheared off, or at least mostly sheared. So this is likely the culprit. Now, there's far more wrong with this bucket than just this, and I'll talk a little bit about that in a minute, but we can see clear evidence here that we got problems. Here's a close-up of that material, and you can see how poor it is. I mean, you would not want to just try and weld something to this, because you know 1/4 inch into that it's still all fatigued and cracked. Now, an interesting question you could ask yourself with this material is it actually mild steel? Now, I ended up welding this with mild steel 1/2 inch plate, and I'm not entirely convinced that this wasn't some form of, not necessarily heat treated, but something like an AR300 or something similar. Like, it's not AR500, but it didn't seem to me, I guess, to be mild steel. Now, realistically, I believe the repair that I did in this video will last, but if it does fail in the future, well, guess what? I'm going to have to repair it and hopefully find out what kind of material this was made out of and use that. More on that later. Let's go on. So step 1 basically involves in torch cutting off all that bad steel. Now for something like this, I generally make 2 cuts. I'll take an initial cut that's maybe like a 1/2 inch from where I want to be, and then I'll take a second cut. Well, the right side of that, I took my initial cut and realized I was so close to what I wanted as my final dimension as far as height off of that curved bucket that I just left it. So the right side was the final cut. the left side I more or less separated that bushing and got it out of the way to where I can get a better cut, and then I went back and did a second cut. And my goal is to be within about a 1/16 of an inch of flat and from the face of that bucket. So I keep the dimension on both of them more or less the same, so I can use rectangle plates, weld those on, and you'll see that shortly, and then basically cut out the shape of the eyes for the bushings. Now, in case you're wondering, this is 1/2 inch thick steel. Like I said, I'm not sure exactly what it is. It didn't weld unusual, so it's possible it was mild steel, not really sure. Now, for a torch, I use a Miller, aka a Smith, an older one that was refurbished, SC209, that, I don't know, is probably older than me. And I'll tell you what, it cuts like a dream. And I'm not the best torch cutter, but this is the finished cut on an initial, and I didn't clean the paint, the scale, or any of that dumpster filth that's on there. That's almost impossible to remove, and there's no dross on it. So I'm telling you, that torch is something else. It does a really good job. Definitely isn't me. I'm pretty inexperienced with using a torch. And by the way, I didn't use a straight edge on this. It would have been pretty hard and time consuming to clamp it on this because everything was bent anyways. So it pays to do a little bit of practice. I definitely need to do more. I could be a lot better. Anyways, let's look at the next picture. So here we can see the left side. I went back and did another cut on that and got it close to being parallel and flat with the other one. I didn't do too bad of a job. I could have had it a little bit flatter. Some video in the future, I'll have to give you some tips and tricks on doing torch cuts like this and then going back and getting it almost exactly flat. And you'll see in a picture in a second how flat it actually became with a grinder. But overall, I'm pretty happy with this, especially because I did absolutely zero prep. Now, in case you're wondering, that black filth that's on there, I don't know what that is other than the fact it's basically dumpster juice, but cleaning that off is almost impossible. I sat there with a pressure washer because this whole thing was completely filthy, just had stuff dripping off of it, and getting that material off is almost impossible. It's worse than powder coating. So, fun times. So now we're looking pretty good. As you can see, the lines are more or less the same height at the top and the bottom, and they're more or less parallel side to side. I didn't get a side shot, but this is the start of where we need to be attaching plates to these. So what I ended up doing after this is basically taking a torch and torch cutting bevels to save the time of grinding them. So here are the torch cut bevels. They look crappier in this picture than they really were. It literally only took about 5 minutes with a hard rock to smooth these out perfect. So that worked better than I would have expected considering how poor the material was. And like I said earlier, I cut off a significant amount of that material. I don't believe in leaving a lot of that fractured and bent up material because you're just going to end up having a failure or crack down the road. Speaking of cracks, here's that pin that broke, and even though it appears gray, it was rusty when I pulled it apart. So what you're looking at is one initial crack, or somehow it sheared and then it held on long enough to where it then shattered or broke and completely sheared off. So this wasn't an instantaneous failure. This was I don't know, it could have been weeks, months, who knows. So here's the first mistake that I made. I had the bright idea of just taking this, torch cutting it off, which I didn't realize how thick it really was. I wasn't paying attention, and I managed to get a rough cut off of it. And I had the bright idea, oh, I'll just push the pin out with a hammer. Well, after hammering on it for 2 minutes, I put it in a 100-ton press, and 70 tons on that press wouldn't push this pin out. And I was afraid the whole apparatus was going to blow out of the press. So I decided to move on to another option. The other side to this actually had a broken off bolt that retained it, and I realized that both of these pins were basically bent in the bore there, and they were never coming out. So I had to source some material to make some new bushings for the pins. Now, I didn't have any 1/2 inch or 3/4 wall tube laying around, and it was like a 4-day wait, I guess, to get a hold of some. So I lucked out, and one of the guys at the shop found me more or less a piece that was exactly the size I needed that happened to be for something else. So you'll see that in a minute. Let's look at the ground down bevels. So here they are, all nicely ground down. I left, I don't know, maybe a knife edge to a 32nd on it. It wasn't really much. And this is my preferred method. Now, I was not going to weld these with a backing bar. I welded it open root and just ran it hot with kind of disregard for what the inside of the weld looked like. And that's because I ground down the inside and then welded it. The inside is a little bit over maybe 1/16 of a gap, and you can see how flat that was. And again, that was all achieved with a pretty rough torch cut and about 5 minutes of grinding total for both sides. It's not that hard to achieve pretty straight bevels with just a torch and a grinder, or just a grinder for that matter. Here's the root pass looking at it from more or less the inside. I welded it from the other side. Sorry for the poor picture, but anyways, I ran really hot, and my sole goal was to melt the two bevels together. Now, if this was something like pipe, you wouldn't want to do what I did, because there's a pretty inconsistent root in there. There's high and low spots in this and lack of reinforcement, but that isn't a big deal with this because I have access to that side to grind it down and then weld it from that side that you're looking at. So that's not really a big concern of mine. Now, a lot of things that I'll weld, I will use backing bars and run on and run off tabs. I didn't on this because of clearance issues with the ram, and I don't know that it would have made it stronger because, again, I believe the failure mode was due to a broken pin and not a direct failure of the plates that were welded onto the bucket. So I root passed both plates, and then I clamped it to a piece of angle iron, and then I tack welded the angle iron to the plates. Now, this looks like they're spread out wider. I actually narrowed them, so it's just the angle of the camera, but they're both pointed inward. And by doing that and clamping it and fully welding it from one side, more or less when the plates pull, they'll pull too parallel to one another rather than too wide. So it's a little trick that you can use to weld stuff at a pre-bent angle, more or less, to where it will bend straight as it cools. Here's a root pass on the right side of it. You can see it's pretty clean, and the bevels aren't perfect, and you know what? They don't need to be perfectly 30 degrees, 15 degrees, whatever it is that you're running. You don't need that to be perfect in order to get a decent result with TIG. And that's one of the reasons why I chose TIG welding for this. It allowed me to flow out metal better on kind of an uneven bevel and not risk defects like I would likely have with stick and possibly to a certain extent dual shield wire. Another reason I chose to do TIG with this is I didn't want to risk having any weld defects top to bottom in this plate, because that hydraulic cylinder has a tremendous amount of force that it can put against that plate, and any defect in this could really be the difference between actually lasting and breaking right the hell off. If I had done this with 7018 rods, which I'm definitely capable of doing, I would have had to have spent a lot more time getting that bevel on the bucket to be more or less perfect, and I didn't want to waste time. So even though it took longer to TIG weld it, the actual setup and weld out, I think this job took maybe only slightly a little bit more time TIG welding it over stick. And again, zero risk of weld defects because I can see what's going on, versus stick. There's a certain element of, I don't want to say hope and a prayer, but if you've done enough uphand stick welding, you know what I'm talking about, especially on something like this. So I think I was about 4 passes deep, and I weaved the cover pass and the second to last pass, and this is the end result. It's not perfect. I ran at about 180 amps and worked as fast as I possibly could to try and get this done, since I believe I took a vacation day or something and I didn't want this to sit in the shop for longer than it had to, especially because I believe that they needed it pretty bad. Here's the other side, the cap pass, and if you're a keen observer, you're going to notice that arc mark up top. When I tack welded that angle iron on there, I went to spit the rod out, and guess what? I had a real nice arc strike all over the plate as it kind of welded itself to it. And you don't want those. I should have ground that down quite a bit, and even better yet, been more careful so I didn't get an arc strike on it. You can see how bad that is right here. And the reason you don't want those on what you're welding, and this is mistake number 2, is that will cause a location for a crack to occur. If that's stressed tremendously, I wouldn't be shocked to find a crack there. And if you just grind the surface down, it doesn't necessarily fix it, especially with high strength steel. You don't want to do this, so be more careful than I was. Anyways, you can see pretty much capped up, looking decent, I mean, for what it is. Now the fun part begins. So I took the new replacement bushing that somebody came up with, put it on the plate, took a bunch of measurements from the back of the bucket compared to the other side, got it to where I think that's where it needs to be. So I used a highlighter and marked the location of it, then used a soapstone so I could torch cut this out. And here we go, soapstoned out more or less what the whole assembly is going to look like once I torch cut it out. In case you're wondering, I freehand almost all of the stuff like this, and it comes from years of doing finished carpentry. You kind of get to the point where you can eyeball stuff and get it to exactly what you want. Here's the result after cutting the first hole. In case you're wondering, I don't have a circle cutter, so I had to do it by hand, and it turned out pretty decent. I'm pretty impressed with how that torch cuts clean steel. I didn't depict it here, but I ended up using the bushing, pushed it through the hole to the other side, checked for square to the face, and then marked where the location was, which gave me a perfect location that's plumb level, true square to it, to where I could cut that out and not have to screw around with remeasuring everything. And I torch cut that one out. Now it's a good idea to leave these a little bit small and use a carbide burr to round them out a little bit in order to get them to fit. These I almost made a little bit oversized because I couldn't really carbide burr them much without losing the tight fit, but luckily they welded out okay, and I stick welded these. I wasn't too worried about the strength or having perfect welds on that. The key stress member were the plates to the bucket themselves. And here are the 2 bushings in place, and you can see the fit is almost perfect on them. Now these were pre-drilled for grease zerks. I actually cut this in half. This is meant for something else, and the grease zerks are not at a point that need grease, but I left them on anyways. And I stick welded these on. Now one of the mistakes, and we'll call it mistake number 3 that I made, is I had the bright idea to weld these bushings on after the plates are welded on, because my thought was I'd be able to maintain a better tolerance to being square for the ram. But come to find out that the bushing on the ram was so worn out, or well, there isn't even a bushing, it's just the eye is worn out, that being perfectly parallel and square really didn't matter. Not to mention the whole way that this ram operates, it really doesn't need a perfectly square parallel pin. So the smarter thing would have been to weld the bushings to the plates off of the bucket, and then spent 5 more minutes to make sure that where the plates welded to the bucket was exactly flat and parallel side to side, and then just weld them on. I'm not joking, it was a pain in the you know what trying to weld the backside of that bushing with almost no clearance. I was using like quarter rods in order to get it, and the TIG torch wouldn't have fit in there anyways, even if I wanted to. I chose to stick weld this because this really isn't that critical. I more or less oversized the welds on both sides just to try and help hold those bushings straight. When everything was said and done, the pin slipped in and out just fine with no grease on it, so it turned out fine. It just was kind of a pain to weld it. Well, it's time to wrap the project up. I went back and torch cut the angle on that. I used a piece of steel to throw the molten metal on so it wouldn't affect the bore on the other side or set anything on fire in the shop. You kind of want to be smart about stuff like that, and a scrap piece of steel works great for that. Here's the mostly finished job, turned out really good. Now the right side bushing, I left a lot more material at the top of it. Since there was no hydraulic hose off the ram there and the ram fit inside of all of that, I knew that I could leave more material to have that a little bit more rigid for more strength, and it wouldn't matter. Now the left side had to be cut down to clear the hydraulic hose on the ram, so I had no choice on that. But the finished product is stronger than what it would have been, I think, from the factory. And since the pin that I put in wasn't broke or fatigued, this shouldn't break off. I ended up drilling the left side for a retaining bolt and used a pin meant for a snow plow that was hardened and basically the correct size, around 1.5 inches. I ended up putting some grease zerks in those holes just to cover them. Like I said, greasing that part, nothing pivots there, so maybe some grease would get to the cylinder, I guess, who knows. And here it is, all completed and ready to go back to work. Now, speaking of ready to go back to work, let's talk a little bit more about the condition of the bucket. I spent a bunch of time looking over the bucket to get an idea of what else might need repair so that it doesn't break in the future, and I found a ton of, well, we'll call it flaws that aren't good. So if you take a look at this, this is the hydraulic ram on the side opposite that I repaired, and there's a bunch of crap wrong here. So the ram clearly moves too much, so they jammed a bunch of giant washers in there. That's not good. I noticed that the bolt that's supposed to retain the pin in the bushing, well, that's gone, and someone just welded the pin in. So guess what? If the pin is defective or has an issue, you have to cut everything apart to get it out. And then on top of it, when I hooked it up to a loader to test its functioning, I noticed that there's about 2 inches of slop in the ram on both sides. So both eyelets on both rams are completely worn out. And unfortunately, the bushing, there isn't one. So it's all part of the ram. So short of TIG welding the bore tighter and then reboring it out, which really isn't feasible, or replacing a ram, there's nothing that can be done to fix that. And after talking with a couple of my coworkers, I realized that this thing has just been one of those that avoided the junkyard 5 times over, and it's more or less a miracle that it's still even operating today. So ultimately, my work was nowhere near what you could call a refurbishment. It was more or less just to extend the life a little bit longer, and no doubt this thing's going to have problems in the near future, and short of putting about every pin and bushing in it brand new, 2 new hydraulic cylinders, and then spending 30-40 hours rewelding all of the cracks and defects that I saw and everything else on this, there really is no way to bring it back to 100% functioning. Now, who knows, with the price of all of the material and rams and all the parts, down the road in a year or two, I might get put in charge of rebuilding this thing back to brand new. Who knows? I mean, the cost of everything's so ludicrous. Like, things you would never think would be done are being done right now when it comes to repair, because financially it makes sense. And there you have it, the start versus the finish, and hopefully the finished product will last. One of the downsides to the type of work that I do is that I repair stuff like this, and then unless it breaks immediately, I don't hear about it. And who knows, it could last years, it could be sold off before it gets broken again. I don't really know, so I try and do the best job that I can in order to have this stuff last. Now, realistically, I would have liked to have replaced the rams on it to tighten everything up, and a bunch more bushings and some pins. But it's truly one of those jobs you kind of have to do what you got to do to get it working again. And it doesn't pay to invest, 30, 40, 50 more hours into it and thousands of dollars in parts when it's kind of on the last leg anyways. So there you have it. Hopefully you enjoyed the video and you learned something along the way. If you got any comments, questions, thoughts, you know where to leave them. Until next time.